Welcome, this is 8.3, identifying the greatest common factor. We talked about factors before. In fact, we talked about prime factorization, where if I gave you a number like, I don't know, 128, then we would do like a factor tree, and we would want to find all of the prime factors, which would be the end of your factor tree. So, for example, you could do 2 and 64, you could do 2 and 32, 2 and 16, 2 and 8, 2 and 4, and 2 and 2. So here the prime factorization would be 2 times 2, 2 times 2 times 2 times 2 times 2 times 2 times 2, or we could also write that as 2 to the 7, I think, since there's 7 of them. Yeah, so we talked about those prime factorizations. Today we're just going to be talking about the greatest common factor, which we'll still be using factors. Let's talk about what a factor is. Okay, so a factor is something that can go into a number. So for example, let's just do an example of 12. What are the factors of 12? Well, what can divide 12 by? So those could be 1. You can divide 12 by 1. You can divide 12 by 2, and 3, and 4, and 6, and 12. Those would all be factors. Factor pairs, in contrast, if we did the same number for the examples, factor pairs are two factors that multiply to give us the original number. So, for example, a factor pair would be 1 times 12, or 2 times 6, or 3 times 4. Those would all be factor pairs. So, here we're going to do some examples. It says, list the factor pairs for the following numbers. Then circle the common factors and identify the greatest of the common factors. All right, so here, if we're going to try and find the prime or the factor pairs, well, I'm just going to want to start with 1. So 1 times what gives you 36? Well, 36. All right, and then we're going to do 2. Can 2 go into 36? And you can just use your calculator if you need to. You could just do 36 divided by 2, and that would end up giving you 18. All right, and then you could try 3. Does 3 go into 36? Well, 36 divided by 3, that gives you 12. And then you can just keep going. What about 4? Does 4 go into 36? Yes, it goes in 9 times. Does 5 go into 36? No, you could put it in your calculator, and it would give you a decimal, which means that it's not a factor. And then we would skip, and so we'd skip 5, and we'd go to 6, and say, does 6 go into 36? Yes, it goes in 6 times. All right? And once you've gotten to the point where you've come back to the right side of your factor pairs, you're done. Okay? So once you've gotten there, then we've written down all the factors. All right, let's try it with 54. So 1 and 54. 2 goes in there. 27. Okay, just want to do 54 divided by 2 will give you 27. Could try 3. Does 54 go into 3? It does. Goes in 18 times. I'm going to try 4. 54 divided by 4. Nope, not 4. We could try 5. 5 doesn't work. We could try 6. 56 divided by 6. That gives you 9. You could try 7. 54 divided by 7. That gives you a decimal, so that's not a good one. We could try 8. 54 divided by 8. That also gives you a decimal. And then we'd say 9, and we already have 9, so we've completed all of the factors. All right, so the next thing it asks for is to list all of says circle the common factors. So here, 1 and 1, those are common factors. 2 and 2, 3 and 3, 4 is not in both of them. 6 is in both. 9 is in both. And 18 is in both. All right? So we've circled all of the common factors, but we want to circle, maybe we'll do a square or something, I don't know, that would be the greatest common factor. Okay, so the greatest, the highest, would be 18. Okay, and we'd write down our answer. 18 would be the greatest common factor. All right, let's do another example, or you can pause and give this a try. So 32, you could do 1 and 32, 2 and 16. 3 doesn't go in. 4 goes in. 4 times 8. 6 doesn't go in. 7 doesn't go in. And then we're back to 8. So there we found all of the factors. I'll do it with 48 as well. So 1 and 48. 2 and 24. Does 3 go into 48? It does, so 3 and 16. 4 goes into it 12 times. 5, no. 6. 6 and 8. And 7 doesn't go in. And then we'd go to 8, and we're back to where we were before. So we don't need to double count or anything. If you did write 8 and then you wrote 6, that would be double counting. So, I mean, it won't mess up your problem or anything, but just extra work that you don't need to do. Okay? Usually, when I do these problems, I don't circle all of the common factors. I just start at the highest. So 32, is 32 in the other one? It's not. We do 16, and 16 is there. So we just circle 16. Okay? Or if you'd like to circle all of them, that's fine. I usually just start at the highest and go down, because then the first one that you hit is going to be the greatest common factor. All right, so here's C. Give this one a try. So 1 and 15. You could do 3 and 5, and that's it. For 28, you could do 1 and 28, 2 and 14, and 7 and 4. Or I guess I probably should have done 4 and 7, just so that it's kind of like in that order. 5 doesn't go in, 6 doesn't go in, and then we're back to 7. So those are all those factors. And then we start at the highest, perhaps, 15. 15's not in both. 5's not in the other. 3's not in the other. So the greatest common factor would be 1. Okay? So it says, how can you tell when the list of factor pairs for a number is complete? All right, we already kind of talked about that, is when it starts to rewrite the ones that are already there. Okay? So here for A, we did 6, and we tried 7. 7 didn't work, 8 didn't work, and then we're back to 9, which is already written. Okay? All right. List the factor pairs for the following numbers, and identify the greatest common factor for those numbers. So here, the difference now is that we have 3. Sometimes we will have 3 terms with a polynomial. So we just need to do it all 3 times. So 1 and 24, 2 and 12, 3 and 8, 4 and 6, 5 doesn't go in, and then 6 is already written there. 18, so 1 and 18, 2 and 9, 3 and 6, 4 doesn't go in, 5 doesn't go in, and then we're back to 6. And then 54, I think we already did it up right above. I'll just rewrite that. So we have 1 and 54, 2 and 27, 3 and 18, and 6 and 9. So now we'll just look and see if we can find the greatest common factor. I'm going to start here because it has the least numbers, least factors for a number. So 18's not in both. 9 9 is in 54, but it's not in this one. 6 is in all three of them, so that would be your greatest common factor. G, there we go. Okay. You can probably skip this if you feel like you're comfortable with 3 terms, but I'll probably go over it. So 1 and 9, 3 and 3, okay, 3 is already on the other side, so we listed all of those terms, or factors. 1 and 30, 2 and 15, 3 and 10, 4 doesn't go in, 5 goes in 6 times, and then we're back up to where we were. Okay, 27, 1 and 27, 2 doesn't go in, 3 goes in 9 times, 4 doesn't go in, 5, 6, 7 doesn't go in, 8 doesn't go in, okay? So there we found all of our factors for 27. So then we're just going to look for the greatest common factor for all 3. So 9 is in the first and the last term, but it's not in the middle term. 3 is in all 3 terms, so that would be the greatest common factor. Okay, 56, I think we did 50, it's 54. So 56, 1 and 56, 2 and 28. All right, does 3 go in? Let's see, 56 divided by 3. Nope, 3 doesn't work. 56 divided by 4. That does, so 4 and 14. 5 doesn't go in. 6, 56 divided by 6, that doesn't work in. 7, I think it's 7 and 8. So 7 and 8, and then here we've got caught up to where we were before. So next would be 8. We already have 8, so we're good. We're done. Okay, and then we'll do 8. So 1 and 8, 2 and 4. And that's all we've got. You could do 3. 3 doesn't go in. And then we have 4. We already have 4. 64. So 1 and 64. 2 and 32. 64 divided by 3. Nope. 64 divided by 4. That would be 4 and 16. 5 doesn't go in. 6 doesn't go in. 7 doesn't go in. Okay, and you can just check these by doing, 64 divided by 7, and that gives you 9.14, and so that wouldn't be a factor. And then we got 64, we can do 8. 8 times 8 is 64. All right, so now we'll look for the greatest common factor. I'm going to start here because there's only 3 that we have to check. So 8, 8, and 8. Check, so the greatest common factor is 8. All right, so here we've been talking all about greatest common factor for numbers. We're also going to have to take out or find the factors for whenever we have variables. So finding the greatest common factor for variables is done similarly, but by writing the expanded form of the equation or exponential expressions. I don't think I'm going to actually teach you that way. Here is we're just going to say, here we just want to figure out how many x's can we take from all 3 terms. So for example, we could take, this has 2 x's, like x times x, this is x times x times x times x, and here there's 5 x's. So how many x's can we take from all 3 terms? All right, well, we could take 1 from all of them. Okay, can we take 2 out? Yeah, we can take 2. Here's 2. Here there's 4, so we could take 2 from there, and there's 5, so we can take 2 from there. Can we take 3? Can we take 3 x's from each term? No, we can't, because there's not 3 to take. for the first term. There's only 2. So here the only thing we can take is x squared. All right, so let's try another one. So when you have 2 variables, you're just going to look at the x's by itself, and then we're going to look at the y's by itself. So here we have x squared, here we have x, here would be x to the 7th. So how many x's can we take from all 3 terms? Evenly. We have to take the same amount from all the terms. Okay, so here's x. You can take an x from all 3 terms. Can we take x squared out of all 3 terms? No, because for this term, there's not 2 x's to take. There's only 1. So the greatest common factor for the x's would just be x. And then we'll look at the y's. We have y to the 3rd, y to the 5th, and y to the 4th. So what's the most amount of y's can we take out from each term? We could take 1, but that wouldn't be the greatest common factor. 2, same. 3, okay, we have y to the 3. We can take y to the 3 from every term. Could we take more than that? Could we take y to the 4th? We can't, because the first term only has y to the 3rd. There's only 3 y's. So you can't take out 4. There's not enough. So that would be the greatest common factor. Here's another example. Looking at the x's, what would be the greatest common factor? We would look at the smallest exponents. We have x squared, and x to the 3rd. So the smallest exponent would be x. Okay? And then what about the y's? How many y's can we take out? And I have a lot of students look at this and say, well, we have y to the 3rd, here we have y, so we can take a y. All right, but we cannot take a y because there's not a y in the first term. Similarly with the x's. There's no x's in the first term to take. So the greatest common factor for all 3 of these terms would just be x. Okay. So the pattern or shortcut you notice with the GCF, or finding the GCF for variables, is that we're always going to take out the smallest exponent for each variable. So here the smallest exponent here was x squared. The smallest exponent for the second term for the x's was x. And similarly for C. Okay. And then like for B, the smallest exponent for the y's was the y to the 3rd. Okay, we do also have a y to the 5th and a y to the 4th, but we can't take more than the smallest amount of each term, if that makes sense. Okay? So let's just do some examples. This is more like what's going to be on your homework and on your tests. It says, when identifying the greatest common factor of a polynomial, you must identify the greatest common factor of the coefficients and the variables. Okay? This is a snow day, and I'm here by myself, but the bells are still ringing. All right, so the greatest common factor, let's start by looking at the numbers. What's the greatest common factor for 3 and 15? Okay, and if you want to, you could do like that thing that we were doing at the very beginning. You could do 1 and 3, and that would be all. 2 doesn't go into it. And then for 15, you could do 1 and 15, and 3 and 5. Okay, so the greatest common factor here would be 3. And then we'll look at the variables. How many x's can we take from both terms? Well, there's not an x to take away on the second term, so we can't take out any x's. So this would be our greatest common factor. All right, so you try and do B. Pause and try that. Here, looking at that, you could do the same thing, 1 and 4, 2 and 2. Here you could do 1 and 6 and 2 and 3. Greatest common factor would be 2. And then for the x's, there's no x to be taken on the right term, so this would be our greatest common factor. All right. And you don't need to write this, but I would recommend doing it if you have any doubt of if you have the actual greatest common factor. All right, next, look at the numbers. If we had a coefficient, it would be 1. So what would be the greatest common factor for 1 and 9? All right, and obviously it's going to be 1. And then we'll look at the variables. What would be the greatest common factor? What's the most amount of x's can we take from both terms? Okay, and again, we look at the smallest, so we can only take out an x. All right, and you could take out the 1, but 1 times x is just x. Okay, I also had students ask about like the sign. Okay, we don't have to worry about that when we're trying to find the greatest common factor. All right, except in one case, and we'll get to that in a little bit. Okay, so try this one. What would be the greatest common factor? Well, what can we divide 8 and 8 by? Obviously, if we did this, we'd do 1 and 8, 2 and 4, and we do the exact same thing on the other one. And here our greatest common factor would be 8. Okay, so we can take an 8 from both terms, and then looking at the variables, what would be the highest amount of variables can we take from both terms? Well, it would be the smallest amount, so x to the 5th. All right, so pause and see if you can do some more of these until you feel like you're confident in what we're doing. All right, so greatest common factor. Here we could do this again, 1 and 7, or sorry, 1 and 14, and 2 and 7. For 28, we could do 1 and 28, 2 and 14. Okay, and here we can already see the greatest common factor. But we could also do 4 and 7. But here we got 14 and 14. So our greatest common factor is 14. And then for the variables, our smallest exponent would be x. So we'll take an x from both of those terms. Okay, same thing. We'll look at the numbers. We got 27 and 81. Had a lot of students get this one wrong, so make sure you pay attention for this one. You may look at this and say, well, I know 9 goes into 81, and I know 9 goes into 27. And I have a lot of students do that and say, well, the greatest common factor is, should I say 7? I meant to say 9, if I didn't say that. Anyway, so 9. But let's see what we get. So 1 and 81. 2 doesn't go in there. You could put that in your calculator. You could try 3. Does 3 go in there? Let's see. So 81 divided by 3, and that gives you 27. And then you could do 9 and 9. So 27, you could do 1 and 27, and you could do 3 and 9. Okay, so here we see the greatest common factor is 27. I mean, apparently, I wouldn't have looked at that and said, oh yeah, 27 goes into 81. Okay, so again, that's another reason to try and do this and writing this all out. So 27 would be the greatest common factor for the numbers, and then for the variables, we'll look at the smallest exponent, so x squared. Okay. Again, greatest common factor here, we can probably fairly easily look at 30 and 40 and realize that our greatest common factor is 10. And then we'll look at the variables. So here we have x and x squared. So this would be the smallest, so x. And then y squared would be the smallest for the y's. Okay. And then here again, greatest common factor for the numbers would be 3. And then we'll look at the x's. The smallest x, again, for this term, for the right side, we don't have any x's, so we can't take x's from either of those. We'll look at the y's. Looks like we have a y on both of them, so we can take a y from both terms. And same as the z's. Z squared, we can take out a z squared from both terms. Gotta love their bells. Okay, identify the greatest common factor for a trinomial. All right, so we're doing the same thing, just we have an extra term. So looking at this, what would be the greatest common factor for the numbers? Well, maybe it's not apparent, so I'm going to write mine down. So 1 and 36. 2 and 18, 3 and 12, 4 and 9. 5 doesn't go. 6. 6 times 6 is 36. And then we're done. Okay, we got back to 6, 12, 1 and 12, 2 and 6, 3 and 4. We completed that. And then for 42, we could do 1 and 42, 2 and 21, 3 and 14. 4 doesn't go in. 5 doesn't go in. 6, I think 6 goes in. So 42 divided by 6, that gives you 7. And then we're up to 7, so we're not going to redo that. Okay, so those are all of our factor pairs. And we're going to want to find our greatest common factor. So I'm going to start with 12. Is 12 in all of those? 12's in the first one, but it's not in the last one. 6. 6 is in all 3 terms. So the greatest common factor would be 6. And then we'd look at the variables. Here we have an x squared, we have an x, and we have nothing. So if there's no x's in one of your terms, then we can't take x's from any of them. Okay? So this would be our answer, would be 6. This one is not written from highest to lowest exponents, but we can still find the greatest common factor just the same. So here, we'll look at the numbers. Here we have 1 and 3. Here we have 1 and 27. And 3 and 9. I think that's it. And then 30, we got 1 and 30, 2 and 15, 3 and 10, 5 and 6. Okay. Hope I didn't miss one. So 27, 2 doesn't go in, 4 no, 5 no, 6 no, 7 no, 8 no. Okay, so I think that's it. And we want to look at the greatest common factor. So is there a 3 in all of them? Yes, there is. So the greatest common factor for the numbers would be 3. And then again, for the variables, there's no variables in the first term, so we can't take a m out from there. So our answer would just be 3. All right, so for the numbers, 10, we got 1 and 10, 2 and 5. For the 3, we got 1 and 3. And for the 5, we have 1 and 5. So the greatest common factor for this one would have to be 1. And then for the variables, the lowest exponent would be r. So our answer would just be 1 times r, or just r. Here's some others. 18, we could do 1 and 18, 2 and 9, and 3 and 6. For 8, we could do 1 and 8, 2 and 4. And for 16, you got 1 and 16, 2 and 8, and 4 and 4. So I would probably look at the smallest number of factors. We'll start with 8. Is 8 in all 3? Nope. Is 4 in all 3? Nope. Is 2 in all 3? Yes. So we can take a 2 from all 3 terms. And then for the variables, we'd look and say, what is the smallest exponent? Which would be n to the 3rd. So we can take 3 n's from all 3 of those terms. Okay, pause and see if you can do E and F if you haven't. So here, greatest common factor. For here, I would just, looking at that, it would be 10. Okay, and then for the smallest exponent would be b, so 10b. F, so we have 3, 9, and 7. The only thing that can go into 7 is 1 and 7. and 7 can't go into 9 or 3. So the greatest common factor for the numbers has got to be 1. And then for the variables, we'll look at all of the h's. So we have h to the 5th, h to the 3rd, and h to the 3rd. So the smallest exponent would be h to the 3rd. And then for the k's, k to the 5th, k to the 3rd, and k. So that would be the smallest. So our answer would just be h to the 3rd, k. All right, so when the leading coefficient of a polynomial is negative, meaning that the coefficient of the first term is negative, like here, the greatest common factor is also negative. So basically, if we have a leading negative, we need to take that negative out as well. So here, let's just do a couple of these, and basically the same. Oops, I try this also. Okay, so here we'd look at the numbers first. So we have 9, 9, and 12. We could do 1 and 9, 3 and 3. Same here, and then 12, you got 1 and 12, 2 and 6, and 3 and 4. So the greatest common factor for the numbers would be 3. For the variables, the smallest exponent would be a. And then since we have a leading negative, the first term is negative, we need to put a negative in front. So that would be our greatest common factor. Okay, same deal. What can go into all three numbers, coefficients? So we could do 1 and 42, 2 and 21, 3 and 14, 4 doesn't go in, 5 doesn't go in, 6 and 7, okay, 48, 1 and 48, 2 and 24, 3 goes in, 48 divided by 3 is 16, 4 goes in 12 times, 5 doesn't, 48 divided by 6 is 8, so 68, or 6 and 8, and 7 doesn't go in. So that completes that. And we have 1 and 30, 2 and 15, 3 and 10, 4 doesn't go in, 5 goes in 6 times. Okay, and then we'll just look at the greatest common factor. Is 30 in all three? Nope. Is 15 in all three? Nope. Is 10 in all three? Nope. What about 6? 6 is in all three. So the greatest common factor for the numbers will be 6. And then we can't take out any x's because there's not an x in the last term. But we do have a leading negative, so we'll just factor out a negative 6. The greatest common factor would be negative 6. Okay. Here, we can't take out for the coefficients. There's not a greatest common factor, so there is, but it would be 1. We can't take out any x's because there's not an x here, but we do have a leading negative, so our greatest common factor would be negative 1. All right, here we go again. Again, if you're feeling good with this, you don't need to. I'll probably put a little too many problems on this. I did do all of these in class. So 54 and 8. Okay, well, this goes in 1 and 8. And I know that 8 times 8 is one of the factor pairs. So the greatest common factor would be 8. Okay, and like I said, you don't need to write all of these down if you're confident that that is the greatest common factor. So like here I did 1 and 8, that was the first one you'd write down, and I know that that's the highest that it can be, and 8 goes into 64, so that is your greatest common factor. All right, and then P would be our greatest common factor for the variables. And then we have a leading negative, so it'd be negative 8p. All right, here it looks like we can factor out a 10 and a d to the fourth, and we need to take out the leading negative as a negative. And then the final one, all right, just looking at this, I think the greatest common factor is 3, but we could maybe start here. We do 1 and 6 and 2 and 3. Does 6 go into 21? Nope. Does 3 go into 21? Yes. Does 3 go into 24? Yes. So the greatest common factor is 3. For the x's, here we have x squared would be our smallest. That would not be our greatest common factor, or x to 3 would not be the greatest. So we get x squared, and then for the y's, there's not a y in the last term, so we can't factor out a y. But our leading negative is negative, so we will factor that out. Okay? All right, well, I think that's everything. If you have any questions, let me know. I'm usually here at 7:15 in the morning if you want to stop by and ask some questions or anything. All right, we'll see ya.